Welcome to Game Developer Unity. Have you ever dreamed of creating your own video games? Starting can be overwhelming, but here's a secret. Even the most successful developers began with small, simple projects. Welcome to the Game Challenge, where we simplify your journey into game development. We have already created two games, Pong and Tic-Tac-Toe. You can check out those videos. In today's video, we'll build a 2D arcade classic, Brick Breaker, and in doing so, you'll learn the core fundamentals of game creation. Today you are going to learn ball and paddle physics, collision detection for interactive gameplay, brick destruction logic and random level generation, creating a game over screen for user experience. So let's get started. Step 1. Let's set up your Unity project. Open Unity, create a new 2D project, and name it Brick Breaker Game. Once your workspace is ready, we'll build the game elements, the paddle, ball, bricks, and a dynamic level generator. For giving a good look and feel of our game, first we are going to add background. Just right-click in the hierarchy, go to 2D, then Sprite and select Square. Select the square and name it Background. Set the position of this background to X, Y and Z to 0. Adjust the square to cover the screen. For this I have set the scale X to 18 and Y equals 10. This will cover our screen. Change order in layer to -1 to it goes behind. Give this background color as you like. I am setting this color to black. Now let's start by creating the paddle. In the hierarchy, right-click and go to 2D object, then Sprite and select Square. Rename it to Paddle. Set its scale to X equals 2 and Y equals 0.5. Position it near the bottom of the screen by setting X equals 0 and Y equals -4. Next, add a component box collider 2D and a rigid body 2D in the paddle game object. Here we have body types option in rigid body 2D. The body type of a rigid body 2D component defines how the physics system interacts with the game object. In Unity, rigid body 2D has three body types: dynamic, kinematic, static. Dynamic for fully physics-driven objects, kinematic for manually controlled motion, and static for immovable objects. Choose based on how your game object interacts with the physics system. Here we are going to set the body type to kinematic because we are controlling the paddle from the controls. Change the color in the sprite renderer as you want the color in the paddle. I am changing this paddle to dark grayish. Now we are going to add one script named paddle controller. This will control the paddle's movement. We are going to attach the script to the paddle game object. I have already set up the script and let's break down the script. Now, let's walk through the paddle controller script line by line to understand how it works. We start by defining a public variable called speed with a default value of 10. This variable determines how fast the paddle moves when we press the arrow keys or other input controls. By making it public, we can easily adjust the speed directly in the Unity inspector. Next, we have the update method, which is called every frame. This is where the paddle's movement logic is handled. Since player input can change at any moment, it's important to check for input continuously within the update function. Here, we use Unity's built-in input.getAccess horizontal function to capture the player's horizontal input. This function returns a value between -1 and 1, where -1 represents a full left input, 1 represents a full right input, and 0 means no input. Next, we create a vector-3 variable called movement to define how the paddle should move. We use the input value for the x-axis, set the y and z axes to 0, and multiply the vector by our speed and time, delta time. Now, why do we use time, delta time here? This ensures that the paddle moves consistently, regardless of the frame rate. Without it, the paddle speed would vary on different devices, making the game unfair or unpredictable. To apply the movement, we use transform, translate, movement. This function moves the paddle in the desired direction based on the calculated movement vector. Next, we need to ensure the paddle stays within the screen bounds. We do this using a clamping mechanism. First, we store the current position of the paddle in a variable called clamped position. We then use the mutf clamp function to restrict the paddle's x position to a range between -7.5 and 7.5. This range represents the edges of the play area. The exact values depend on your game's screen width and camera setup, but you can tweak these to fit your design. Finally, we assign the clamped position back to the paddle's transform, ensuring it cannot move out of bounds. With just a few lines of code, we've created smooth, responsive paddle movement while ensuring it stays within the play area. Now let's go back to the Unity editor and let's create a ball of our game. Let's add a new 2D circle. In the hierarchy, right-click and select 2D object, then sprite and select circle. Rename this square to ball. Set its scale to x and y to 0.3. Set its position just above the paddle. Add two components to the ball, circle collider 2D and a rigid body 2D. In rigid body 2D, set body type to dynamic. Set the rigid body's gravity scale to 0. To make the ball bounce, we are going to use Physics 2D material. Create a Physics 2D material by right-click in the project folder. After right-click, select Create, then 2D, select Physics 2D material. Rename this material to Ball Bounce Material. To make the ball bounce, set friction to 0 and bounciness to 1. Assign this material to the ball's circle collider 2D. We are also going to set the color of ball. Set as you like. I am going to set this color to red. For ball, we are going to make a little tail effect. For a tail effect, we are going to add a trail renderer in ball. Change the shape of the tail as you like. Set time to 0.5. Set the color as you like. I am going to set red, the same as the ball but a little transparent. Just set the material to default. For launching of ball and detect collision with brick, we are going to create another script named Ball Controller. Attach this script to the ball game object. I have already set up the script. Now, let's dive into the ball controller script. This script manages the ball's behavior, including launching it, detecting collisions, and interacting with other game objects. First, we declare a public variable called speed with a default value of 10. This determines how fast the ball moves once it's launched. Next, we define a private rigid body 2D variable named RB. This allows us to directly control the ball's physics. We also have a Boolean flag, is launched, initialized as false. This keeps track of whether the ball has been launched yet. In the start method, we use getComponent rigid body 2D to grab the rigid body 2D component attached to the ball. This setup is essential, as it enables us to control the ball's velocity and physics interactions later in the script. Next, we have the update method, which runs once per frame. Here, we check if the ball hasn't been launched yet, using the isLaunched flag. If the player presses the spacebar, input, get key down, key code, space, we launch the ball. To launch the ball, we set its velocity using the RB, velocity property. We create a new vector 2 with a random x value between -1 and 1 and a fixed y value of 1. This random x value ensures the ball doesn't move straight up every time, it adds variation to the gameplay. We then normalize this vector to ensure its direction is consistent, and multiply it by the speed variable to control the magnitude of the velocity. Finally, we set isLaunch to true to prevent the ball from being launched repeatedly. Now, let's move to the collision logic. The onCollision enter 2D method is triggered whenever the ball collides with another object. We use the collision GameObject.tag to identify what the ball has collided with. If the ball hits a game object tagged as brick, we call the brick destroyed method from the game manager script. This method handles brick destruction logic, such as updating the score or checking for level completion. After that, we destroy the brick using destroy collision game object. If the ball collides with an object tagged as game over zone, we call the game over method from the game manager script. This could trigger a game over screen or reset the game state. Finally, we destroy the ball using destroy game object to remove it from the scene. And that's it. This script handles launching the ball, its interactions with bricks, and ending the game when necessary. With just a few lines of code, you've added dynamic gameplay to your Brick Breaker project. Back into the Unity editor for creating a ball prefab, just drag and drop this ball game object to the prefab folder in the project tab. Delete the ball in the hierarchy tab. Now for the fun part, the bricks. Let's create another 2D sprite and name it brick. Set the tag of this game object to brick. Set its scale to x equals 1 and y equals 0.5. Now we are going to add Box Collider 2D in the brick. Drag this brick into the prefabs folder to make it reusable. First, create an empty game and name it Level Generator. Next, we'll use a script to generate random levels. Here I have created a script named Random Level Generator that will generate random levels while you hit play. Attach this random level generator to the level generator game object. I have already set up this script. Let me break down the script in detail. Random level generator script, which not only creates a grid of bricks but also introduces randomized colors and keeps track of the total number of bricks. This brings extra vibrancy and functionality to our Brick Breaker game. First, let's go over the variables. Brick prefab. This holds the reference to the prefab we'll use to create the bricks. Make sure to assign this in the Unity inspector. Rows and columns. These control the number of bricks arranged vertically and horizontally. Brick width and brick height. These define the size of each brick to ensure proper spacing. Spacing. This adds space between the bricks for a clean layout. Brick probability. This determines the chance of a brick appearing at each grid position, giving us random gaps in the layout. Random brick color. An array of colors we'll use to assign random colors to the bricks. Finally, number of brick keeps track of how many bricks were successfully created. This can be useful for scoring or level progression. The heart of the script lies in the generate random level method, where all the action happens. Let's break it down step by step. First, we calculate the starting positions for the grid. StartX determines the horizontal starting point so that the bricks are centered on the screen. It takes into account the total width of the grid, including spacing. Starty sets the vertical starting point for the top row of bricks. Next, we use nested for loops to iterate over each row and column in the grid. These loops help us position the bricks in a structured layout. Inside the inner loop, we use random value, which generates a random number between 0 and 1. If this number is less than or equal to brick probability, we proceed to create a brick at this position. This introduces randomness into the level layout, ensuring no two games are exactly the same. The position of each brick is calculated dynamically. The x-coordinate is based on the column index, brick width, and spacing, added to StartX. The y-coordinate is determined by subtracting the row index times the brick height and spacing from Starty. This creates a grid-like arrangement of bricks. To create the brick, we use the instantiate function. This clones the brick prefab at the calculated position, with no rotation, and assigns it as a child of the random level generator object for better organization in the hierarchy. After creating the brick, we use the random brick color array to assign a random color to each brick. This adds visual variety and makes the game more engaging. The color is applied by accessing the sprite renderer component of the brick and setting its color property to a randomly chosen value from the array. We also increment the number of brick counter each time a brick is successfully created. This keeps track of the total bricks in the level, which can be used for gameplay logic, such as checking when all bricks are destroyed. Now let's get back into the Unity editor. To keep the ball within the screen, create invisible borders using 2D sprites with Box Collider 2Ds. Set these borders to top, bottom, left and right. Tag the bottom border as Game Over Zone. Next, create an empty game object and name this object Game Manager. We'll create a Game Manager script to handle the game's logic. Attach this Game Manager script to Game Manager game object. I have already set up this one. Let's break this down. Game Manager script, the central hub for managing the game's state and flow. It controls tasks like spawning the ball, generating levels, counting bricks, and handling game over scenarios. We begin by defining a static instance of the Game Manager class. This makes it a singleton, ensuring only one instance of the script exists, which we can easily access from other scripts using Game Manager instance. Next, we declare references for critical game objects. Ball prefab, the prefab used to spawn new balls. Paddle, the paddle's transform, ensuring the ball spawns just above it. Level generator, a reference to the random level generator script, which handles brick placement. We also include variables to track the remaining bricks, a game over UI to display the game over screen, and internal methods to manage game logic. In the awake method, we assign this instance to the static instance variable. This ensures the Game Manager script is globally accessible during gameplay. The start method initializes the game when the scene loads. First, it calls the reset ball method to spawn the ball above the paddle. Next, it uses the level generator, generate random level method to place bricks in the scene dynamically. Finally, it calls count bricks to count the total number of bricks, ensuring we know how many bricks need to be destroyed to complete the level. The reset ball method creates a new ball at the position slightly above the paddle. This is done using the instantiate method, which spawns the ball prefab at a calculated position. The count bricks method tracks how many bricks are in the level. It retrieves this value from the level generator number of brick, ensuring that the game knows when all bricks have been destroyed. When a brick is destroyed, the brick destroyed method decreases the remaining bricks counter by 1. If the number of remaining bricks reaches 0, it calls the level finished method, signaling that the level is complete. The level finished method logs a message that the level is complete. It also regenerates a new random level by calling level generator, generate random level, and resets the brick counter by calling count bricks again. The restart game method reloads the current scene to reset the game. This is achieved using Scene Manager, Load Scene, Scene Manager, Get Active Scene, Build Index, which restarts the scene from scratch. Finally, the Game Over method is triggered when the game ends. It logs a Game Over message and activates the Game Over UI to display the Game Over screen to the player. This is our Game Manager script. Let's get back to Unity Editor. Finally, let's add a scoring system and a Game Over screen. Create a UI text object for the score. In the hierarchy, right-click and go to the UI and select Text, Text Mesh Pro. This will add one text in canvas. Set UI scale mode of canvas to scale with screen size. Select this text and rename it to the score text. Set this text as you want. I am setting this text to the right corner of the screen. I am also going to use a different font for this. Now create an empty game object named its Score Manager. Then create another script name, Score Manager, and assign the script to the Script Manager game object. I have already set up the script, let's check it out. Score Manager script tracks the player's score and updates the score display on the screen. First, we declare a static instance variable, making this class a singleton. By using Score Manager instance, other scripts can easily access the score management functionality from anywhere in the game. The script includes two key variables. Score text, a reference to the Text Mesh Pro UI element that displays the score on the screen. Score, an integer initialized to 0, which keeps track of the player's current score. In the awake method, we set the script's instance variable to the current instance of the class. This ensures that there is always a single point of access for managing the score throughout the game. The addScore method is where the magic happens. When called, it does three things: logs a debug message, adds score to the console for debugging purposes, increases the score variable by the number of points passed as an argument, updates the score text UI element to reflect the new score using the format score current score. For example, when a brick is destroyed, this method is called with a point value. The player's score increases, and the UI immediately updates to display the new total. The script connects seamlessly with the rest of your game. The game manager or the ball controller can call Score Manager instance, add score points, whenever a player earns points, ensuring that the scoring system remains centralized and easy to manage. With this script in place, the player gets real-time feedback on their progress, adding a rewarding and engaging element to your game. Now let's go back to the Unity editor and create another panel for Game Over. In the canvas, right-click, go to UI and click on Image to create a panel for the Game Over screen. Rename it to Game Over Panel. Now click here in the Rect transform and click Alt and select Stretch. Set the opacity of this image as you like. I am doing 0.5 and making this color to black. Add a text object with the message Game Over. Also add the button for Restart. We are all set to go. Now at last, just assign everything that our script needs. Let's start with the paddle controller. Select the paddle and set the speed of the paddle controller as you want. I have set it to 10. Next script is the random level generator, which is in the level generator game object. Drag brick prefab from the project folder to brick prefab field in the inspector. Set this value as you want. Here we also have a list of brick colors that are going to be assigned when the brick is instantiated. Choose any number of colors and set them. Let me do that quickly. Now let's move on the next. Next is Game Manager. Drag and drop ball prefab. Assign a paddle from hierarchy. Then drag level generator that has a random level generator script. At last assign the game over the panel from the canvas. Then select the btn_restart and click on plus sign and drag the game manager object here and select the restart game function from the script. Also don't forget to deactivate the game over panel. Next select the score manager game object which has the script score manager. In the score manager script assign score text from the hierarchy. Now we are set to test our game. Click here on the play. The ball is launched when you hit the space on the keyboard. And there you have it, your very own brick breaker game. In this tutorial, you've learned how to implement key concepts like paddle system, ball physics, random level generations. These skills will be invaluable as you tackle bigger game dev challenges. If you enjoyed this video, don't forget to like and subscribe to Game Developer Unity for more tutorials like this one. Until next time, happy coding.